So the first planet around a sun-like star outside our solar system was found in 1995. After that, astronomers have carried out many campaigns to look for those planets. And to date, there are 2,000 planets have been found. So we know there are planets outside our solar system there. But it is unclear how those planets form. We know planets form in protoplanetary disks, which are gaseous rotating circumstellar disks surrounding newly born stars. We basically know within a few million years, the dust grains and gas in those disks has to be assembled together to form planet, but we don't know exactly how that happened. It would be great if we can directly resolve those forming planet in disks, but in practice it is extremely difficult because the planets are so small and they're so faint comparing with their host stars. And also because the young stars are very active, so the traditional planet hunting methods do not work in that regime. But the forming planet in disks may still reveal themselves from the signposts they produced in disk, from the gravitational disk-planet interaction. For example, we know giant planets like Jupiter can clear the material around their orbits in disks to form gaps. And thanks to the advanced observational techniques and telescopes which have come online in recent years, we are starting to be able to resolve this kind of structure. So the recent image we took using the 8.2-meter Subaru Telescope for the PDS 70 system is just one of these examples. So in this system, what we see is a bright outer disk and a heavily depleted inner cavity. The size of the cavity is about 60 or 70 astronomical units, or about twice the orbital radius of Neptune. The heavily depleted cavity, we suspect it's very likely to be opened by planets, but because the size of the cavity is so big, it is probably opened by several Jupiter-like planets, not by a single one. So by studying the observations of the system, we hope to put constraints on the properties of the planet, particularly their masses and their orbits, so that we can find a way to directly constrain theoretical models of planet formation using observations. So the first planet around a sun-like star outside our solar system was found in 1995. And ever after that, astronomers have carried out many campaigns to look for those planets. And to date, we have found more than 2,000 planets around sun-like stars. So we know there are planets out there. But it is still unclear how those planets form. We know planets form in protoplanetary disks, which are gaseous rotating disks surrounding newly born stars. There are dust grains and gas in the disk, and basically we know within a few million years those stuff has to be assembled together to form planet, but we don't know exactly how that happened. Of course, it would be great if we can directly resolve the forming planet in disks. However, in practice, that's extremely hard because planets are very small and faint in comparison with their host stars. And also the young stars are very active, so that traditional planet hunting methods do not work there. But on the other hand, the forming planet in disks may still reveal themselves from the signposts they produce in disks. So we know giant massive planet like Jupiter-style planet can clear material around their orbits to form gaps in disks. So the first planet around a sun-like star outside our solar system was found in 1995. And after that, astronomers have carried out many campaigns to look for this planet. They're very successful, and today we have found more than 2,000 planets. So we know there are planets out there outside our solar system, but it is unclear how those planets form. So we know planets form in protoplanetary disks, which are gaseous rotating stellar disks surrounding newly born stars. There are gas and dust grains in the disk. We basically know within a few million years, those gas and dust has to be assembled together to form a planet, but we don't know exactly how that happens. It would be great if we can directly resolve the forming planet in disks. However, that is extremely hard in practice because the planets, they're very small and faint in comparison with their host stars. And also because the young stars, they're very active, so that the classical planet hunting methods don't work in that regime. But the forming planet, may still reveal themselves in disks from the signposts they produced from the gravitational planet-disk interaction. So we know giant planet like Jupiter can clear material around their orbits to form gaps in disks. And these days, thanks to the advancing observational techniques, we are able to resolve this kind of structure. So the recent image we take for the PDS 70 system using the 8.2 meters Subaru Telescope give us an example of such kind of structures. So in this image of the system, we see a bright outer disk, but we also see a heavily depleted inner cavity, which is about 60 or 70 astronomical units, or about twice the radius of the Neptune's orbital radius. So the cavity in this system, we think it's very likely to be opened by planets, but because it is so big that a single giant planet probably cannot do that. We probably need more than several such kind of Jupiter-style planet to open the cavity. So by studying the structure of the cavity and the other disk from fitting the observations, we hope to put constraints on those currently insane planet candidates, especially their mass and their orbits, so that we can directly learn how planets form in disks.
Is that it?